question 2. So question 2 is where I ask you to determine the value of A in each of the following. So we have 4 questions in question 2. And the first one is basically to find probability of Z less than A equal to 0.75. And what you see here, the value that we need to find is the value of A. So how do we do this? Yeah. So just to show you how the proper way of doing it is basically, this is where we assume that the normal distribution has been standardized in such that you can see we all are using Z here. It's already been standardized. It's not X anymore. So that's an indicator that it has been standardized. And the area under the curve for this particular question, for the first one is 0.75. That means about 75%. Yeah. So in order to do this, the diagram of it, because Z is less than A, and you can see given here your A is a positive value, so it lies on the positive area, and the shaded region here is the area that indicate the 0.75 or 75% in total. So the green area is only the balance area of the total area, which is equal to 1. Yeah. So in this case, we can basically find what is the value of A by just doing the complement of it. And as you can see, to indicate the green area, we use 1 minus 0.75. That's why we get 0.25. Yeah. And hence, you can see the area is representing the green area. So this writing is probability of Z greater than A is the green area. So by doing this, we are still looking at the same value of A. Yeah. So this is one way to look at it, corresponding to the shaded one for 0.75. The 2.05 is referring to the green area. So the purpose is basically just to find the value of A, right? So once you already identify that, which is 0.25, and therefore you just have to look at your table. Let me show it to you. Hey, I didn't show it here, is it? I thought I did show it here. Never mind. But you know how to get the 0.6745? Do I need to show you the table?
No.
Huh? You know how to get the A?
Oh, yeah.
Okay. And then the next one is in between negative A and A. So it's 0.8. That's the area under the negative A to A. And we want to find what is the value of A. So this is how the diagram should look like. That means the area, as you can see, the shaded one is enclosing the 0.8. And you can see negative A to A. Yeah. So from here, what we do is we can use the total area 1. You minus the green area. This is a representation of the green area. And the other one is representing the other green area, which is on the positive side. One is on the negative side, and the other is on the positive side. So if we use the total area 1 minus this green area and minus this green area here, that would give us the balance of the 0.8. Yeah. So from here, basically we can summarize it that we have 2 of the same, because the probability of Z less than negative A is symmetrical with probability of Z greater than A. And as you know, we don't deal with a negative value. So the best thing is use the symmetrical concept of it. So we have 2 of the probability of Z greater than A. Yeah. So from here, therefore, what we have is probability of Z greater than A is equal to 0.1. Do you know why it's 0.1 here, class? Is because the balance is 0.2. Because 1 minus 0.8, you only have 0.2. But since there are two areas, we have to divide by 2 of the 0.2. So that's why we only have 0.1 here. Yeah? So therefore, yeah, therefore, you just need to check from your table, the short table, yeah, and that corresponds to 1.2816.
Miss,
Mm,
why the answer have 4 decimal place?
come again?
Why the answer have 4 decimal place?
Oh, because you need to check from the table. Let me
Because
show.
the table until 2 decimal place.
The table until 2 decimal places. Which table are you looking at?
The first one.
The short one or the long one?
Or the long one also can use.
You can, but you have to find, because this is the other way around. So you need, I think it's much more practical to use the short one because we have the area. The area is 0.1. So the best way is to look at the shorter table. Let me just verify. Let me go to the table. It's the lecture. Chapter 4. My computer is very, very slow. Oh dear. Is it open already? Is there a table here? Oh no, it's not here. Right? I did share it in the Google Classroom. That means I must get it from a different subject. Okay, so we have it now here. There, it's red from here. I cannot edit it there. But you can see from my arrow, yeah, 0.10 is 1.2816. So it's better you read it from here. If you see that, Noel, 0.10, it's 1.2816. Okay?
Oh,
Okay, so if you use the long table, also can. If you use the long table, this one, you're required to do like this. So that means you need to find 0.1. Yeah. So if you do 0.1, the nearest you can get is, you see here 0.1. Can you see my arrow? 0.1003, isn't it? that is the nearest to 0.1. Yeah, so that corresponds to 1.28, 1.28 lah, kan? So you can still find the answer from this table, but you need to see the one inside. Yeah, but if you use the shorter table, which I call it this one, it's very easy to just look at 0.1 and you get 1.2816. So using the short table, I call this as a short table, it is much more faster, because all this value, the alpha value here, this column, this column, this column, all the alpha column is showing us the area. So it's faster to find the answer in this manner.
Oh, I get it.
Is that clear?
Yeah.
Yeah. So that's how we can get the answer of 1.2816. So that is the value of our A lah. So here on the negative side, it will be negative 1.2816. So I know I've been informing you that when we want to find the A or even the X, this is in reference to the X or the Z, we only look at 2 decimal places, right? But because we are looking at the table for the answer, therefore we get 4 decimal places. So it is possible for us to write to 4 decimal places. But if you write your answer to become 1.28 only, it is still accepted because you use the long table. So it doesn't mean it will be a wrong answer. It will not. Yeah, it will not be a wrong answer. Okay,
Oh,
Noel.
okay.
Okay. So we move on to the next question. Yeah. The next one is probability of Z is less than A is equal to 0.05. So this is the area 0.05. So basically, in this case, it didn't tell us it's a negative, but you see it's a less than. So less than, it's always referring from the left, and the area is only 0.05, or rather about 5%. So you can see it's on the negative side of the diagram. So for this, it's similar to probability of Z greater than negative A equals to 0.05. It encloses the same area as well. And from the table, let me first think about it. Negative A is 0.05. Let us check 0.05. Let me go to 0.05. I'm going to the short table. Yeah, correct. You see, 0.05 is 1.6449. Yeah, so because of that, that's why you see here. I've created another one. Yeah, that means the negative A with reference to 0.05 is equal to 1.6449. Yeah, and hence, therefore, the A is equal to negative 1.6449 because, as you can see, it only encloses 5% of the area, and you can see it's Z less than A. So therefore, our A is a negative 1.6449. I hope that is clear. Yes, any question, anybody?
No.
All clear, is it? Okay, so if all is clear, we go on to the D question. Now this time, again, we still have already standardized, and it's between A greater than A, but less than negative 1.5, and the area is 0.0418. So it's a very small area, yeah? So in this case, the diagram of it will let us see that this is the area enclosed, about 4.18% only. And we definitely know the A would be a negative area, yeah, on the negative area, because already the other value is negative 1.5. So how do we proceed on this is that when we do it the other way around, what do you say? Probability of 1.5, whereby the Z is greater than 1.5 and less than negative A, equal to the same area, 0.0418, we can basically rewrite it in such that probability of Z greater than 1.5 minus with probability of Z greater than negative A is equal to 0.0418. So let me get my pen. It's better. I think there's some value is not correct. It's supposed to be positive 1.5. Okay. I mean, in terms of symmetrical of it. Then this one should be positive. And we know the area for Z greater than 1.5 is 0.0668. This one you have to check out from the long table. Yeah. In reference to PZ greater than 1.5, you get 0.0668. And basically, we have already been given with this area 0.0418 from the original question, right? So in order to solve this, that means we just have to subtract these two values. That gives us a balance of 0.025, yeah? And therefore you just have to check from the table of the value, the short table, 0.025, and that corresponds to 1.96. Yeah, so that's your answer. Now the reason why it is placed as negative negative here, you can see it's negative, is just so that you do not get confused that basically the A is on the negative area, but the calculation is done assuming as in it's on the positive side. That's why the 1.5 is assumed as Z greater than 1.5. It's the symmetrical of it. Yeah, I hope that is clear. Any question? Do you understand, is it? Because we are using the symmetrical concept of it. You might have your own way of understanding it also, yeah, but in this sense, we are using the long table for the value of 1.5, convert it, you get 0.0668, and then based on the area that was given, you just subtract it, you get 0.025, and this you check out from the short table, yeah, and checking out from the short table, you will get 1.96. Of course, we put it negative because this is the value of the A originally as drawn. Yeah, because based on what was given to us, it is on the negative area of the normal diagram. Yeah, so I hope that is clear for everyone. Okay, so we move on to the next question if there is no difficulty in understanding this. So let me know, yeah, if you have any problems in understanding this solution. Now the next one is question number 4. Yeah, this is about the lengths of rods normally distributed, and the mean is 120. Standard deviation is 1.5. what percentage of the rods would you expect to measure over 122.5 millimeter, and the other one is between 116 millimeter and 124 millimeter. Yeah. So here what you have to do is to identify what are the parameters. We have the mean and standard deviation. So this is how we write it. X follows a normal. How do you know it follows a normal? Because it's already written, it is a normally distributed length of rod. So the mean is 120 and the standard deviation is 1.5. Again, take note, when we write this notation, you must make sure that it's written in terms of the variance. You see, 1.5 to the power of 2. Yeah. So once we have done that, we want to find probability of rods over 122.5 millimeter. So for that, we need to standardize it. At the moment, it's X greater than 122.5. You standardize it. So that means 122.5 minus with 120 and divide by 1.5. What value do you get from the calculation here?
uh, 1.67.
That is correct. Yeah, it is 1.67. And of course, you can see the Z is already greater than 1.67. It's based on our table. So you just need to check from the table, and that should give you 0.0475 as your answer. So this question is pretty much straightforward, isn't it? No tricky question, nothing. And if you look at question B, just for you to check your answer. Oh, yeah, I forgot about the percentage. What percentage of the rods? Yeah. So basically, you need to multiply the value of 0.0475 times 100%, and that gives you 4.75%. Have I discussed this with you guys?
About what?
Huh?
The percentage?
No, the answer. This one.
No.
I have?
No.
Oh, okay. I feel like I have. Well, anyhow, so this is what the final answer should be. It should be written 4.75. Yeah, because the question asks you to write, or rather, the question asks what percentage, yeah, of the rods you would expect to measure over 122.5 millimeter.
So if my answer is 0.0, it's wrong already.
Yeah, because you didn't answer the final answer, which was a percentage. You lose just a bit of marks, lah, not a lot, just a
Oh.
bit of marks. Yeah, because you still get the marks for the working all throughout until here, but it's just that you didn't write this. You might lose just, maybe 1 mark from the total answer. But if let's say the question, yeah, it's only 3 marks and you lose 1 mark, sayang, no? Kan? To lose
Yeah.
that 1 mark. Okay, the next question is between 116 millimeter and 124 millimeter. So for here, we need to standardize it. So standardizing it, you can see X is between the two numbers given. So standardize means you minus the mean and you divide by the standard deviation. And this will give you two values, which is the same actually, to find the probability of negative 2.67 to 2.67, negative and positive. So that means the value of Z is in between. So as you know, questions like these, let me just draw a very simple normal distribution just to help you guys to understand it. it will be negative 2.67 here. And here would be a positive 2.67. It's all enclosed within this area. And that means the best thing to solve it is using the total area 1 and minus 2 of the area of 2.67 because it's symmetrical. Yeah. So when you check from the table, the long table, yeah, 2.67, you should get 0.00379. And when you have 1 minus 2 times 0.00379, you get 0.99242 as the final answer. Okay, any question? Oh, not yet. Does the question ask for percentage as well? Yes. So you should get your answer as 99.24%. Any question, class?
No.
Okay. So if there's no question, we move on to the next example, next tutorial. Again, this is pretty much straightforward, yeah. It's still a normal question. We have less than 2,200. You have between 2,300 and 2,700. And then you have 2,300 and 2,400. And then more than 3,000. So this one is quite easy. Why did I ask you guys to do this? So never mind. We let X be equivalent to the operation life of component XYZ in ours. So it is declared it follows a normal distribution. You can see here the word normal is stated. So we write X follows a normal. The mean is 2,500 and the standard deviation is 250. So in order to answer part A, at the moment it's less than 2,200, standardize it, you will get Z is less than negative 1.2, which it's on the negative side of your normal distribution. It is best to transfer it symmetrical to the positive side. So you just have to check from your table. You should get 0.1151. Did you get the same answer?
Oh, yeah.
Okay. And then the next question is between 2,300 and 2,700. Standardize it. Get two values. We've been discussing about if the values is between negative and positive, just like what you see here. So when you have question like this, it is best to solve it using standardization. Using the complement. Total area is 1 minus 2 of the same thing because it's symmetrical. So you have 1 minus 2 times probability of Z greater than 0.8, which if you check from the table is 0.2119. Yeah, so subtracting them, you should get 0.5762. Any question, class?
No.
Yeah, this question is pretty much straightforward, but expect the same, yeah, in your test as well. Okay, moving forward to the next question. This one I'm going to go faster because you will realize it's almost the same as in the lecture notes as well. It's just that now when you look at the one already standardized, the area is on the negative side. Yeah. So of course here we do symmetrical. That means we have to find the area from 0.4 to 0.8. So it's already standardized, right? So you just have to check from the table probability of Z greater than 0.4 minus with the probability of Z greater than 0.8. Now remember, it doesn't mean the bigger the value, then the area is bigger. In this case, remember 0.4 is closer to the value 0, therefore it's a bigger area. Yeah. So when you check the value from the table, you get these two values, and therefore the answer is 0.1327. And same goes with question D. Standardizing it, you get Z greater than 2. Oh, this is very straightforward, this one. It's just finding the area for 2. So you get 0.022751. Any question?
For the seat, why the modern symbol is like the other way around?
Oh, okay. Because if I draw it, you see, this is the area it originally asked. It's on the negative side, it's negative 0.8 to 0.4. Negative, isn't it? This is what it shows. Yeah?
No. Okay.
And then, because when we're doing symmetrical, we have here 0.4 and here is 0.8. So this is the area that we want, because we cannot find from the negative side. So in symmetrical it, we have this. But you see, why is it that we want to find the answer? Why is it it's greater than? It's because we are looking at the first area, which is the 0.4 only. 0.4 will cover all the way here. This is 0.4 until the end. And then we deduct the 0.8. So 0.8 is here. So when you deduct the 0.8, this is the only area. So that's why Z greater than 0.4. Why do we put greater than? It's because in accordance with the table that we are using, if you look at the table we are using, it is actually showing a greater than symbol. So in order to denote the area for 0.4, that's why we have to use the greater than.
Okay.
I hope that is clear, Noel.
Yeah.
Okay, yeah. So that's how we solve question 5. Any other question, everyone? Anybody? Okay, so no question here. We go on to the next one, question 8. Now this is more interesting. Just now was quite boring, the question, because it's the same style as before, right? But this one is what you should expect, in exam, yeah? So it tells us that it follows a normal distribution. And the mean is 500 grams and the standard deviation is 10 grams. We need to find the probability that the randomly selected packet will contain between 501 and 515 grams of cereal. So this question here, you can see that it's a normal distribution portion and the random variable is about the weight of the cereal in grams. Yeah, so it follows a normal whereby the mean is 500 and the standard deviation is the value of 10. So what do we do here is, first of all, question part A is to find between 505 and 515. So this one you need to standardize it, because you see, now it's still an X. So standardizing it, you get these. Okay, now from here, when you calculate this, you should get 0.5 to 1.5. So you can see, if you draw the diagram to it, the 0.5 is much bigger. In fact, in one of our exercise, it's exactly, in one of our example, it's exactly the same case, yeah, 0.5 to 1.5, which you split them up by finding the probability of Z greater than 0.5 first, and then you minus probability of Z greater than 1.5, and get that values from the table, is what you see here, and subtract them, and that would give you the answer. Any question? So far, okay, yeah?
Oh, yeah.
So for question B, we are to determine the weight of cereal such that 10% of the packets are containing weights more than this. So this is a probability value given to us. So that is why we denote A as equivalent to the weight of a cereal, because we don't know what's the value of the X. So I'm using a different lettering to indicate, oops, there's a baby crying up there, to indicate or to find the value of the weight of the cereal, yeah, such that 10% of the packets are containing weights more than what was stated. So in this case, it's probability of X greater than A, which gives us a 10%, which is 0.10. And do the standardization, just like as in the notes. You see the X change to become a Z, the A you minus with the mean and divide by the standard deviation, and it's equal to 0.10. So from here, you need to check, of course, the value of 0.10 from the table and the short table, okay? And that gives us 1.2816. And just to highlight to everyone, yeah, the child is crying upstairs. Can you hear the child crying?
No.
Okay. So you see, the weight more than this should be an indicator that it's greater than. So that means we start from the right side of the table. So this area will give us the 10%. And therefore our K will be here, our A will be here, and it's a positive value. So with that, that's why the value is here, 1.2816, which you check from the table, is positive, because as you can see, it's on a positive area. And because of that, we were able to find the value of the A by cross multiplying it, and then you plus them, yeah, which gives us the answer. Yeah, if you calculate this, that means 1.2816, you times with the value of 10, and then you plus 500, and your A would be 512.816, or rather equivalent to 513 grams. That's the answer. Okay, any question? No question? All
Uh,
clear?
um, why must be one 513 grams? Cannot have decimal.
Well, you can leave your answer as decimal. I mean, 512.816. It's still accepted, but this is just an option. Yeah, to
Oh.
approximate it. Because normally when we measure anything in, let's say you measure, this is about the weight of the cereal, right? So if you look at the packets, yeah, normally the packets that you drink, like 3-in-1, the weight are not written in terms of up to many decimal places. It will be rounded to a whole integer like this. So this is just to how do you say, make it rounded figure. But if you leave your answer like this, 512.816, it's still acceptable, and it is rounded to 513 because you look at the 8 after the decimal point, it is more than 5, right? So it's obviously possible to add another one to the value 2. So that's why we got 513 grams as the final answer. You can leave your answer in decimal, yeah, Noel. It is not the problem. Um, but if you round it, before you round it, make sure you write this value as well. So some students, they just leave the answer like this without rounding it, but it's already correct. But if you decide to round it, it is correct as well. But if there are cases, you see, student now, they already got the correct answer, but when they go and round it, they go and give me a wrong answer like this, 512. I've experienced that. Yeah, the student already got the answer, but they go and round it again, and that cause how do you say, deduction of marks. So be careful about that. Yeah. Any question? No
Uh,
question.
no.
Okay. So with that, we go on to question number 10. Yeah. And in this case, yeah, we have the mean, yeah, the weight of a randomly chosen grape of a given variety is a normal variable with mean 5. Standard deviation is 0.123. And the question asks us to give our answer correct to 2 decimal places. So this one, you have to be careful in terms of your answer because it's already stated there. The answer must be in 2 places of decimal. And then show that the probability that the randomly chosen grape weights the weight more than 9 is 0.0102. Yeah. So in a way, this is just to show your answer, but from the information we obtain, we know X is the weight of grapes in grams. This is what the data is available for us to use. And therefore, X follows the binomial with the mean equals to 5. And then your standard deviation is not given. Yeah. The standard deviation, given that the probability that a randomly chosen grape weighs less than 3 grams is 0.123. Yeah. So this is the 0.123 is the probability value class. Yeah. So in this case, what information that we have here is that, say we standardize it, we know our mean is 5, and you can see here, let me get my, the chosen grapes weigh less than 3. Hang on, it should be less than, yeah. It's less than 3. Should be less than, this symbol should be less than 3. I mean, this one here should be less than. But let me, this, I won't change it now. Because this is given, yeah, 0.123. That's the probability value already stated in the question. Yeah? And therefore, referring to the table, the short table, and if you check it out from the short table, the 0.123, 0.123, yeah, we are not able to get the value because you can see here 0.123, we only have 0.10 and 0.15. So that means we cannot immediately get the value. Yeah. So what we do from here is we're going to use the long table for the value of 0.123. So looking at the long table, you can see it's there. 0.1230. It corresponds to 1.16. So that means 3 minus 5 over the standard deviation is equal to 1.16. Yeah, that was what my concern was because, oops, sorry, I dropped something. Yeah, so you see here, let me go back to the original question. Yeah, it says less than. So if for me to do this normally, I would consider, I won't write it there. Can you hear the child crying now? Still cannot.
Okay.
No. It's disturbing me though because the child is crying outside the house and the house is slightly, on a higher hillside compared to my house. So the noise is quite loud. But anyway, for me, I would go and use the less than because then I can visualize how the diagram would look like. But this is considering with the standard deviation. So because we know what is the value of the weights, 3 grams, right? But for me, I would always consider a negative area because the question stated less than 3 grams. So I would consider that this area here is corresponding to the 12.3%, which is the 0.123. So definitely it's on a negative area. Okay, it should be negative here. So as we work out the solution just now, you can see that here, once we identify the value as 1.16, we put a negative here because of what I've drawn just now. It should be on the negative area. And that, therefore, if you do the calculation, you cross multiply. Yeah. And then, of course, 3 minus 5 is negative 2. And therefore, the alpha, sorry, the sigma divide by negative 1.16. And that's why you get 1.72 as the answer. Okay, class? Any question? Hello?
Mm, no.
Hmm? So that's why we have answered the question. The question, if you look at it originally, it has no, how do you say? It doesn't give us the value of the standard deviation. Yeah. So that's why find the standard deviation, it says here. Yeah. Given that the probability, and of course we are to give our answer correct to 2 decimal places now, which is 1.7. Any question? No question, is it?
No.
Okay. Then there's another part that asks us to show. So that means probability of x is greater than 9. So based on the new standard deviation that we have obtained, don't use the one with 1.72 because this one you already truncated it and the value might lose its accuracy. So what we do is we use the one with 4 decimal places. So for the value of 9, we standardize it. You see x now becomes a z. 9 minus 5 divided by 1.7241. We get 2.32. And of course, you get 0.01017, which is basically about how many percent? 1%? Yeah, that's it. Let me just go and have a look at the question. Yeah, we want to choose that it's 0.0102 and weights more than 9. And you can see in the solution here, it is obtained. Okay, any question?
No.
All right, okay. So we go on to the extra example, the one that I asked you to do, because we did the binomial and the Poisson, I think. But I didn't ask anything about the continuity correction here. Just simple question. Like this one, it's about 35 is your n, and among 10 randomly selected customers, what is the probability that less than 2 wants the mid-size version? Mid-size version and oversized version. 35%. Yeah, this is the percentage. That means 0.35 wants the mid-size version. Yeah, and our n is only 10. Yeah, who wants this type of tennis racket? We need to find the probability that less than 2 wants the mid-size version and more than 2 want the mid-size version. So to solve this, you must state X be the number of customers who wants the mid-size version out of the 10 randomly selected customers. Because in this question, we have 2 parameters, the N, which is the value of 10, and 35%. Yeah, stated in the question, they want the mid-size version. So basically, we can say that the random variable x follows a binomial whereby our n is 10 and our probability of success is 0.35. So answering the first question, we want x is less than 2. So of course, if I want to find x is less than 2, I only need to calculate 0 plus 1. Do we need to calculate the 2? No. Yeah. So we only have to add 2 values, x equals to 0 and x equals to 1. So put it into the formula, as you can see here. Yeah, 10 combination 0, because our x is 0, yeah. 0.35 is the probability of success. Therefore, the probability of failure is 0.65. This is the 1 minus q. So you have for x equals to 0, here to the power of 0, And 10 minus 0, you get 10 also here. Same goes when x equals to 1. So you calculate all this, and that will give you 0.08595. Is that okay?
Yeah.
Yeah. And then the next question is x is greater than 2. Now, for x is greater than 2, we can calculate from the value 3, because it doesn't include the value 2, right? So that means you have to add the value 1, the value 3 plus 4 plus 5 until 10. That is a lot to calculate manually.
And not 1
The-
minus.
Yeah, of course, that's what we need to do. It's too troublesome to calculate from 1, and I mean from 3 plus 4 plus 5 until 10. So the best way is to use 1 minus x equals to 0 minus x equals to 1, and you minus again x equals to 2. So when you do all this, yeah, you minus, because you already got the answer earlier, the only one that is left to calculate is based on the formula is this. And basically, your final answer should be 0.7384. Did you get the same answer?
Yeah.
Yeah. Okay, good. Right. So any question on this extra example? None?
No.
Yeah, you can see in the question, let me just go back to the question here. There is the value of the marks allocated for this question. It's about 4 marks. Yeah, so that's the normal allocation of marks for this question. Um it's about like what you see now, about 4 marks per question. So that is what you will expect the same as well. Yeah. So I hope everyone is clear about this. No other question?
No.
Okay. So we move on to the next question. Yeah. This is about a Poisson. Sorry about the spelling wrong. This is a Poisson question, and this is about emergency room traffic and the number of patients arriving between 6 and 7 p.m. It has a variance of 6.9. Yeah. Determine the probability that on a given day, the number of patients arriving exactly 4, at most 2, and between 6 and 10 inclusive. Variance, is it not the mean? Hang on. This question is a bit wrong, class. This one with a variance, it should be with a, must be in a hurry. Because if it's the lambda, yeah, this should not be the word variance. This should be the average. Sorry about that if you have solved it. Because how could you solve a Poisson with the variance? Not possible, okay? So let me just edit that. There was a mistake in that sense. So the first question is 4, I think. So X is the number of patients arriving between 6 and 7. So the lambda for the Poisson, it follows the Poisson, is 6.9. So for this, the first question, it asks for exactly 4. So when it's exactly 4, there's no problem to it. We just replace the lambda with 6.9. Remember, there's a negative here, so sometimes students tend to forget to put the negative. That's why the answer is totally wrong. And then times with 6.9 to the power 4 and divide by 4 factorial. So you get 0.0952. That's your answer. The next question is for x less than or equal to 2. So I don't remember the question though. The question states at most 2, yeah? So at most 2 means we only have to add 0, 1, and 2. So you just have to do, there's no other way to do it. There's no other shorter way to do this. So this is how you do it. So you have to add all of those small values. And that's your answer, 0.0320. And then the last question is basically asking between 6 and 10. This one also, you got no choice. You have to calculate each one of them. And that gives you all this answer, 0.5948. Okay, so is that clear?
Very long
Last?
to write. Yeah. Formula very long.
Yeah. A lot of students, yeah, they skip this part. Yeah, they skip this writing. They don't show this on the answer. They immediately show this value because the marks would come from here. This must be shown so that the examiner will know that you know what is being added. If you skip writing this part, whereby it's the second part here, you can. But of course, the answer must be shown now. You mean this one, the formula? Yeah. Provided you got all the values here correct. Yeah. If not, still, it's based on this, it will be deducted. Your marks will be deducted. Yeah. What is important is this one, Farah. This one must be shown now. Because then we know that you know what you need to add up. Yeah. So yeah. Any other question? That's it. All the question. Of course, the question that I give out today is quite straightforward, simple. Yeah. We'll try and look at a more challenging Poisson question and binomial question next week. Yeah. I think that's all for today. I didn't even give you guys a break, did I? So any question concerning this? Chapter 4. We finished chapter 4. So next week on Monday, be ready to cover chapter 5. Any question, anybody?
No.
No? Okay, Farah said no question. How about you, Calvin? Any question?
No.
No. If you have no question, then that's all for today. I will still be here until 2:30. If you have question, you're welcome to ask me. If not, then you can leave because I have nothing else to cover. And somehow I didn't even give you guys any break at all, isn't it? But you guys still okay, right? If there's nothing else, thank you very much. That's all for today.
Okay. Thank you, miss.
Thank you. Bye bye.